Okay, many of you have approached me this with this doubt over the weekend. What is significance level? Okay, firstly, I'm glad that you're all studying, so it's a good thing. Secondly, it's perfectly all right to be a little confused. It is a tricky concept, but not very difficult. When it finally clicks, you'll wonder why you even had the doubt in the first place. Okay, so let's just first get the definition. The definition for alpha is the probability of rejecting the null hypothesis when it is actually true. It also corresponds to your type 1 error, which is also alpha. Okay, what does this really mean? Let's get into let's get some fundamentals first. Okay, so now this is your normal distribution. You have your mean mu and sigma, standard deviation sigma. Okay, the probability of finding a value within one standard deviation, which is this region, is approximately 68%. The probability of finding something within two standard deviations, which is this entire region, is about 95%. Now, when a value is two standard deviations away from the mean, okay, it's somewhere over here, then we call it an outlier, or in other words, it is significantly different from the mean. It is a notion. We accept values within two standard deviations as not being so different from the mean because we are allowing for a little tolerance. Okay, so this area over here is acceptable for all practical purposes. Now, what does the null hypothesis say? Okay, the null hypothesis says that the sample statistic estimate is equal to a population parameter. Okay, so we are okay if the actual population mean is within two standard deviations or 1.96 standard deviations of the sample statistic estimate. But what if the value falls beyond the acceptable levels? Okay, as in this case, the value falls here instead of in our acceptable region. Right? Then we say that there is a significant difference between what we hypothesized and what the actual reality is. Okay, when we write down this equation, mu is equal to x bar plus or minus s by root 10 into number of standard deviations, we are assuming that it is a good sample. We are assuming that this x bar is representative of the population, and hence we are able to make an estimate, an interval estimate for mean mu. Alright, now extending the same logic to two means from two samples belonging to two different populations, my null hypothesis H naught would be that mu A is equal to mu B. Okay, and my alternative hypothesis would be that mu A is not equal to mu B. Now, this is my mu, this is my 97.5 region, this is my 2.5 region. So these areas are my outliers. And if my mu B happens to fall here, then I can say that mu B is significantly greater than mu A. And if it falls here, then I can say that mu B is significantly less than mu A. But in either case, mu B is significantly different than mu A. Okay, some of you said that the sample is significant. The sample is not significant. The difference between the two means is significant. Alright, so now imagine the same thing for the sampling distribution. Now I have the distribution. What is the probability that I would accept a bad sample? Okay, if I'm rolling dice, okay, if I'm taking pure chance, then all the samples, all the good samples, 95% of the samples must be within this region. And the bad samples would be coming from here. It is like they are the outliers. Of course, you are going to get a few bad samples, but we're saying that it should be less than 5%. We know that we can never have zero errors. We're going to get zero bad samples. That is never going to happen. But we have let a tolerance. We have said it is okay as long as I am getting 5% bad samples. So if I take 100 random samples, then I'm okay if I'm gonna get 5%, 5 bad samples. Okay. If I'm taking 1,000 samples, then it's okay if I get 50 bad samples. Those are the levels that I'm comfortable with. All right. So what does alpha really mean? It is the probability. It is the probability of rejecting the null hypothesis. So you have been a little hasty in rejecting it. You took a bad sample and you rejected it. That chance, the probability of rejecting the null hypothesis should be less than 5%. Alpha should be less than 5%. Now, let's take a look at what it means in terms of linear regression. In linear regression, okay, we say that our beta naught is equal to 0. That is our null hypothesis, that beta naught is equal to 0. Now, when your p-value, which is the observed significance, okay, p is equal to observed significance. I'm saying that I want 5% significance level, but what is the actual significance level? That is your p-value. When I say p is less than 0.05, it means that my beta naught is not equal to 0. Okay, I'm 95% confident that the intercept for the line is not 0, it is something else. How much is it? You will find it in the estimate column. You'll find it in the estimate column. You will be able to see a value, say for example 2.5. That is the estimate for beta. Then you will have the p-value. The p-value has to be less than 0.05. If the p-value is not less than 0.5, then we do not actually accept the alternate hypothesis. We fail to reject the null hypothesis. Okay. In any case, let's just revise what alpha meant. Alpha is the probability of rejecting H naught when true. The H naught is actually true, but you are rejecting it. The probability of doing that should be really low. Okay, it should be 5% or less. It also corresponds to your type 1 error. The type 1 error is the error of accepting a bad sample. Okay, this corresponds to the same thing. You should not be accepting a bad sample, and also the probability of rejecting a null hypothesis when it is true should be as low as possible. That is what significance level means. Please understand, samples are not significant. The difference is significant. The difference is always significant. I can say wages of men significantly greater than women. I can say salaries in Bangalore significantly different from Chennai. Okay, so these are the things. It depends upon how you have defined the null hypothesis. It depends upon how you have defined the null hypothesis and uh, how you are actually looking at it. Please understand that if I've taken this thing, if this is my mu A and mu B falls here in the dark zone, then there is a significant difference. Mu A is not equal to mu B. Hope this clarifies your doubts. Please do let me know.